Okay, in the last lecture we stopped in here in this slide 29. Okay, we'll start from here 30. So anyway, the reaction kinetics order of we already finished the first order kinetics, right? Now we are into second order kinetics. Second order kinetics, the way it says that the reaction proceed at a rate directly proportional to the second power of the single reactant being converted to the single product. Okay, that means double of those. That means the rate two of them A will be converted to the product. So that means in this case we can say dc over dt is proportional to c to the power 2 because second order, right? So then if we take out the proportional, then negative sign k would be the because it's changing, so that's why it would be kind of like a negative sign. Okay, k square. Integrating this equation, because we didn't show it here whole detail, but I can do the separation of variables. So the way we do the separation of variables, it could be this dc over c square equal to negative k dt, right? So now if we do the integration and put the value like say this is c0 and this is c and this is t and this is 0. I took k out of this because of k is a constant, right? It's a constant. Then the equation becomes like that. So okay, equation becomes like that. This can be plotted. This is looks like a straight line, right? We plot this way is a 1 over c here, and this way is the time. This should be my 1 over c y-intercept, and the slope would be the k, positive k in this case. Okay, so we'll be using those concepts later on in different topic. Okay, then water quality, physical characteristics are pH, then color, turbidity, TSS, taste and odor, and temperature. How the pH is physical? Because physical has to be like, say, if you can sense it with the five senses that we have. One is we can see, we can hear, we can smell, right? Okay. Then we can feel into our what is called in our skin, and so on. These are the one. So five senses we can use to see whether it's how it is physical. pH. If you put your finger in the low pH solution, you'll never able to see it anything, right? Then definitely it will burn. So TSS, it should be very clear. Total suspended solid, you should be able to see it. And turbidity, because turbidity is given by the effect of the light scattering due to the suspended solid. So you should be able to see it. Color comes from both, like say, it's come from suspended material as well as the dissolved materials, and we can see it, the color difference. If it is not crystal clear, we should be able to see it. Okay, taste and odor, we can taste it because we can put it in our tongue, right? So definitely an odor we can should be able to smell it with our nose. And the temperature is physical because if you have high water or very cold water, if we put our finger in there, then we should be able to feel it. Okay, that's how their physical characteristics. And lab a book have a lot of description of more of those things, all of the physical characteristics. Chemical characteristics, any chemical that we may not be able to see it, so but only under the testing procedure or under testing we should be able to know it. So that's called the chemical characteristics, right? Chloride, fluoride, iron, lead, all of those are kind of chemical characteristics. EPA's priority pollutant list, 40 CFR 131.36. That means Title 40 CFR section 131, subsection 36. They are more clearly explained over there. Then microbiological characteristics, basically microorganism in there. So total coliform is one way to measure those. The mostly widely used test estimate the number of microorganism in the coliform group. Fecal coliform, total coliform, the other way group that. The grouping includes two bacteria genera is Escherichia coli and Aerobacter aerogenes. So these are the two. Okay, fecal coliform is another one that comes from the women and animal and other things like that. Why coliforms are selected as an indicator organism? Common events of intestinal tract excreted in large quantities can survive in water are relatively easy to culture. That's why the E. coli is or coliform, right? Coliform means E. coli. So Escherichia coli, E. coli. You heard the name E. coli several times in spinach issues, right? And some of the cases, even different other product, they have had issues or contaminated with E. coli. Radiological characteristics. The effect of human exposure to radiation or radioactive materials are very harmful. Radiation is nothing but a emission of gamma rays with high strength that can destroy our nervous system, human nervous system, and can make the harmful. Humans have always been exposed to natural radiation from water, food, and air. The amount of radiation to which the individual is normally exposed varies with the amount of background radioactivity to very high. So water with high radioactivity is not normal and is confined in great degree to areas where nuclear industries are situated. We have seen the Fukushima incident over there. So there was a leak or something. That's why a lot of people got affected, right? Fukushima power plant, nuclear power plant, and other things because they had a water with high radioactivity and people got exposed to those things. Water quality standards is very important because we have to know the standard to compare with and know that this is good quality. So President Ford signed the National Safe Drinking Water Act into law in 1974, December 1974. So he was directed to establish a maximum contaminant level, that means MCL, for public water system to prevent the occurrence of any known anticipated adverse health effect with an adequate margin of safety. So that's the one. So MCL defines as the maximum contaminant level, and these are the one parameter that parameter has a health effect. It says the adverse health effect. Okay, so table 6.2 in page of our and 6.4 in our textbook has those values in there. And in my lab book, I have some of those in my lab book also. Okay. So the next one is the secondary maximum contaminant level, SMCL. So SMCL is also certain national safe drinking water act provided additional set of standard to prescribe maximum limit for those contaminants tend to make water disagreeable to drink or use. Not pleasant to drink or it doesn't look good. It may be safe but may not be good. That means other way we can call it wouldn't have any particular health effect, adverse health effect. So this would be in table 6.5. So then American Water Works Association has some goal, okay, in addition to those. The goal are something we desire to have it, but it's not kind of something that we can enforce, okay? So the primary and secondary maximum contaminant levels are the maximum allowed. Our reasonable goal may be much lower than MCLs themselves. Okay, types of water quality standards. Again, it differs into four part of it: physical, chemical, biological, and radiological. Okay, water classification and treatment system. So there are two sources that we discussed in topic 2, right? So always the surface water and the other one is the groundwater. Surface water are contaminated with a lot of suspended materials, bacteria, viruses, inorganic substances, and so on that can have a health effect. Groundwater may contain high concentration of calcium, minerals, I mean the dissolved particles, a lot of those, manganese, magnesium, further classified as two source, deep or shallow wells and other things like that. So both of them may need some kind of treatment before we can make it potable, I mean safe to drink and palatable. Okay, these are the treatment system. This table gives us a very good idea of different type of pollutant and the how we measure it, so how much is in there in the lab, then what kind of treatment process or technology we can use to remove those. The first one is suspended and colloidal materials, solids, turbidity, color, TSS, TS and TSS, total suspended materials. This is total solid and total suspended solids. Coagulation, flocculation, sedimentation, and filtration. These are the process should be able to remove those parameters or reduce those suspended and colloidal particles. The next one is the dissolved solids, pH, because pH is a negative, logarithmic of hydrogen ion concentration, right? Color, as I said, color can come from both suspended solid, colloidal, and dissolved solids. Okay, so then TDS, total dissolved solid, hardness, alkalinity, metals, and THM, trihalomethane. Trihalometane comes from the chlorination of water, chlorofluorobromoiodine, halogen group, and other things like that. So chemical precipitation, softening, and adsorption, these are the treatment processes can be used to remove those. Suspended and dissolved solids could be even both form, could be nutrients, nitrogen and phosphorus, could be both suspended and dissolved form, depending on how they are in the state, chemical precipitation and biological treatment. And organics could be also as a dissolved or suspended. We measure it through BOD5 and COD. Chemical and biological treatment process can remove those. So we'll see all of those in topic 5, right? How to reduce those BOD5 and other things. Microorganism and pathogens, E. coli, okay, total coliform, fecal coliform, salmonella, and other pathogens. These are the indicator of those. Could be more, but I'll just say disinfection is the treatment process, can be used to remove those microorganisms, kill or deactivate their nucleus. One is the chlorine, ozone, and UV rays. These are the three processes we can do the disinfection. Okay, treatment system. There are simple classification would be disinfection, filtration plants, and softening plant. So that means either we do surface water, groundwater, both requires disinfection. Filtration is for surface water and softening is for groundwater. So plants employing simple chlorination have a high water quality source and chlorinate to ensure that the water reaching customers contains safe bacterial levels. Generally, filtration plant is used to treat the surface water and softening plants are used to treat the groundwater. Okay, filtration is for this and softening is for groundwater. Okay, here a little bit more description of filtration plant, okay, and softening plant. Rapid mixing, flocculation, sedimentation, filtration, disinfection are employed and remove color, turbidity, taste, and odor, and bacteria. I mentioned it over there, right? So additional operation may include bar rack, course rack. It again depends on where we are getting the water from. Softening plants utilize the same unit operations as filtration plant but use different chemicals. The primary function of softening plant is to remove the hardness. Now hardness is mainly calcium, magnesium. In the lab class, we'll learn more detail what is hardness means and how we things like that. Calcium and magnesium mainly. Chemical doses are higher in softening and the corresponding sludge production is greater in this case. More sludge will be produced during the softening process. So here is the one is surface water. Okay, so water is coming to the screen. Rapid mixing, flocculation basin means adding some kind of chemicals here, lime mainly, ferric chloride or aluminum sulfate. These are the two coagulant that we use. Sediment basin, sedimenting sludge is coming out, then is going to the rapid sand filter. After the filtration, we add the disinfectant here, then it goes to the storage, then we pump to the distribution system. Okay, so you have seen those distribution system in topic 2, right, for our supply system and so on. Here is the one for the groundwater. So rapid mixing, reaction basin, where we need to have the pH up to 10.3 to 11 to have the precipitation in there. Then the settling tank, sludge is coming out of it. Then recarbonation. Since pH was higher over here, and pH has to be going down because of this is the pH range for the drinking water, right? So, but here pH was almost 11, so we don't want to accept that. Then we go to the filtration unit, then disinfection, and goes to the storage and to the distribution system. So these are the simple flow chart of treatment process for a surface water and groundwater. This is for groundwater. The one before was the surface water. This is a treatment system flow diagrams. Basically, what it means is, like, so this is a control system. They call it SCADA. Okay, SCADA means they can control everything from this room, where it's happening, how much is happening, starting from the water level to everything. Okay, so we are going to stop here.